Hey guys, Mr. McKinney here, just doing part 2 of the Unit 3 review video. First, we're going to go over the derivative rules for exponentials and logs, and then we'll talk about linearization. So when we talk about exponential and log functions, the derivative of an exponential doesn't change unless you have the chain rule. So the derivative of e to the x is just e to the x. The derivative of e to the u is e to the u times the derivative of u, or u prime e to the u. This is just the chain rule. So you don't have to memorize this one if you understand the chain rule. You can just use this rule with the chain rule. Same thing over here. The derivative of the natural log of x is 1 over x. The derivative of the natural log of u is 1 over u times the derivative of u, which can be rewritten as u prime over u. If you want to memorize this one, you can, but it's just the chain rule version of this one. So you need to memorize these two rules, and then you need to be able to apply the chain rule with these two rules, or you need to memorize these two. All right, and this is a complicated example that's going to put it all together. So we have 3x squared multiplied by ln of 5x minus x multiplied by e to the 7x minus 2. If you want to, hit pause and try to work it out and see how you do. All right, let's see how you did. So first of all, this minus means that I'm going to treat the first half and the second half separately. I can find this derivative and then just subtract this derivative. So over here, I'm going to have u and v. So I'm multiplying u and v, so I'm going to need to use the product rule. U equals 3x squared, u prime would be 6x, v equals ln of 5x, v prime would be 1 over 5x times the derivative of 5x, which is 5. And then those 5's cancel out, and you get 1 over x. So for this first part, I need to do v times u prime plus u times v prime. So v was ln of 5x times u prime was 6x, plus u was 3x squared, and then v prime was 1 over x, minus, and then we'll switch to red for this other piece. So over here, let's use what letters? R and S. So we'll say this is R and this is S. I didn't want to use U and V again to get you guys confused. So we're going to end up doing S times R prime plus R times S prime. So R equals X, R prime would just be 1, S equals e to the 7x minus 2, S prime would be e to the 7x minus 2 times the derivative of 7x minus 2, which is 7. So here I'm going to do S, so e, and I'm going to put brackets around to make sure I distribute this negative to everything. E to the 7x minus 2 times R prime, which is 1, plus, and then R is X times S prime is 7 e to the 7x minus 2. And then since I have 4 terms and they don't have anything in common, my final answer, and this is the derivative, my final answer is just going to have 4 terms in it. There's not really a better way to simplify this one. So I'd have 6x ln of 5x. I just like to put the 6x in front. Here I can cancel out an x, so I'd cancel those out and get 3x, and then distribute the negative in here. So minus e to the 7x minus 2, and then minus 7x e to the 7x minus 2. Technically, you could pull the e to the 7x minus 2 out of both of these. You could pull a 3x out of both of those, but you don't need to. All right, last topic in this unit was linearization. Linearization really just means use the tangent line to approximate. So when you see linearization, just say to yourself, tangent line equation. Find the tangent line equation, and you'll get at least some credit on the exam. So again, a linear approximation is just a way to approximate a function's value by using a linear approximation, by drawing a line. This is the formula that you guys would need to memorize, but technically you don't really need to memorize this formula if you understand what it's representing. it's really just saying point slope form. So here's point slope form. Y minus y1 equals m times x minus x1. For our linear approximation, our x1 value is a. So a is just x1. Our slope is the derivative of f, so f prime of x1 or f prime of a. And then f of a is just your y1 value. And instead of having y minus y1 on the same side, we just moved that y1 over. So you can memorize the linearization formula, but you don't really need to. You just need to recognize that linearization is telling you to use the tangent line equation. So let's look at a couple of examples. Find the linearization of f of x equals the square root of x cubed plus 1 at x equals 2. So I'm going to need a point and I'm going to need a slope. I'm not even going to think about it as linearization. I'm going to think about it as point slope form. So I have a point, and then I'm going to find another, or I have half of a point. I'm going to find the other coordinate. Y1 is going to be f of x1, which in this case is going to be the square root of 2 cubed plus 1, which is 3. So I have my point, 2, 3, and now I need to find the slope when x is 2. So if f of x is equal to x cubed plus 1 to the 1/2 power, then f prime of x is equal to 1/2 times x cubed plus 1 to the negative 1/2 power, and then I need to make sure I multiply by the derivative of the inside function, so 3x squared. I want to know when x is 2, so let's plug in 2 right here. F prime of 2 is going to be 1/2 times 2 cubed plus 1 to the negative 1/2 times 3 times 2 squared. So 2 cubed plus 1, that's 9. 9 to the negative 1/2 means 1 over the square root of 9, so 1/3. So I've got 1/2 times 1/3. 4 times 3 is 12. So 12 times 1/2 times 1/3 is 2. So my slope is 2. So basically, I'm just doing y minus y1 equals m times x minus x1. Y minus 3 equals 2 times x minus 2. And then linearization just wants you to get y by itself, so add the 3 over. So L of x equals 3 plus 2 times x minus 2. This is your f of a. This is your f prime of a, and this is your x minus a. So you can use the linearization formula, or you can just use point slope form. So to estimate 2.1, I would use this equation. L of 2.1 equals 3 plus 2 times 2.1 minus 2. This would be on the non-calculator portion. So 2 times 0.1 would be 0.2. 3 plus 0.2 is 3.2. Basically, linearization is a way that you can figure out approximate values of difficult functions without using a calculator. So for example, if I wanted to estimate the square root of 80 without a calculator, I could say, okay, let's pretend f of x is the square root of x. I don't know the square root of 80, but I do know that the square root of 81 comes out evenly. So I'm going to do it at x equals 81. I'm going to draw the tangent line equation for this equation at that point, and I would use it to estimate. So once I find the linearization, I would do the linearization of 80. Same idea here. My original function would be the cube root of x, or x to the 1/3 power. I don't know the cube root of 60. I do know the cube root of 64. So I would be doing the linearization of this function at x equals 64, and then I would be finding L of 60. So again, when you hear linearization, just think to yourself, use the tangent line equation. So just find the equation of the line that's tangent to the function at that point, and that is your linearization equation, and just use it to estimate a point. Hope this was helpful. Good luck getting ready for the test.